Okay, so as requested, I'm just going to give a simple, kind of no-nonsense um, detail about ellipses and lesson on ellipses. So the first thing that I want you to look at is, let's look at the circle. Um, if we dissect the circle inside, uh, inscribed inside of a square, I want you to notice a few things. If we divide it into quadrants, just half and half, it's going to meet the midpoint of the square, the lines of the square, uh, and that circle has a tangential relationship at those midpoints. That's going to hold true if we put that inside of an ellipse. So if we draw an ellipse inside of a square box, that square has to be proportionally accurate, but it is in perspective. The same thing holds true. If we divide that ellipse into quadrants with these two vanishing lines, one going to the right vanishing point, one going to the left vanishing point, going through the center of the ellipse, it will meet the midpoints of those lines. Those are the midpoints in a tangential relationship. And that's one way to construct an ellipse. To check the ellipse, we've talked a lot about the chord. And I've shown the chord here just in an orthographic top view of this circle. And what that chord does is it basically gives you an even division of a small area. And you really want that chord line to be somewhat close to the exterior line of the square that the circle is inscribed within. And it helps you visualize it. It's more difficult if, for example, the chord line was up here. It would be more difficult to see an even division once we get it into perspective. And so you want to get it somewhat close. It just helps our eye discern whether or not it's correct. And so you can see here, even though those have vastly different shapes, this one gets a little bit thinner up here, this one's a little bit wider, but it looks like an even distribution. And again, the analogy that we used is that if you ran a pizza slicer, if this was a piece of pizza that was cut in half this way, and you ran a pizza slicer across this blue chord line, it ultimately would give you an even distribution. And basically, to show you what would not look right would be a line like this, which doesn't give you an even distribution, or a line like this, which would not give you an even distribution. And so when you check this, that's going to help you see whether or not it works. This is true for an ellipse that's on a horizontal surface. So we've really got three different scenarios. We've got this one up here. We'll call it 1. It's on the horizontal surface. 2 is an ellipse that essentially is facing left, at least to the viewer. And 3 is facing right. And so there's a couple of things to think about with relation to the chord. If it's on a horizontal surface, you're actually going to use 2 to create that chord. You're going to use vanishing lines. You're going to use one that goes through the center towards the right vanishing point. You could do it the other way as well. And then you're going to use one going towards the opposite vanishing point, this blue line right here, that's going towards this left vanishing point. But just to show you how this could work the other way, you could use a line going through the center, this line right here, and then and going towards the left vanishing point, you can strike your chord line going towards that right vanishing point. So I'll just do that and show you that it works. It would work either way, and again, that creates that even distribution. With a left-facing ellipse, you're going to use the vertical. So you're going to use this vertical line going through the center, and then you're going to use a line going towards the left vanishing point to check the chord. The minor axis, remember, is going to be going towards the opposite vanishing point of the direction that the ellipse is facing. So for this left-facing ellipse, the minor axis, which is the most important thing on all of these, the minor axis for this horizontal ellipse, or ellipse on a horizontal surface, it's going vertical. This one's going to the right vanishing point because it's facing left, and this one's going to the left vanishing point because it faces right. However, the chord will be the opposite of whatever your minor axis is, and so you can see here it's divided. Now, I've drawn it on these two and it is on the bottom of this ellipse. But if we just like we could use a different way to find a chord here, we can also use a different way to find a chord on these two. And so that line is going towards my right vanishing point. Both of those will go towards the same vanishing point. Whether they're both going to be the opposite of whatever your minor axis is. And so that's just a breakdown of how these work. So let's just say that we have a square. One way that many people use to construct an ellipse is they'll draw what they feel is a proportionally accurate square surface, and then they'll put that ellipse inside of it. So they'll draw it around where they want that ellipse. And so we already have established vanishing lines, and so therefore established vanishing points here. But what we need to do is we need to find the center of this, and some people can guesstimate where the center is, and some people cannot. It's going to be somewhere about right there. And then because this is on a horizontal surface, we're going to use a vertical minor axis. And so again, what that is that when I take my ellipse template and set it on top of this, I want to make sure that I'm lining up my minor axis with that vertical. And so let's put this right on the center. And then as I make this larger, it does not seem to fit in there, right? So it's coming out over here. So this ellipse doesn't seem right. Let's go to a different one. Let's go to this one. So again, my minor axis is on that vertical. But this ellipse, even if I shrink it down, that's not the right one. As we pointed out on the last page, the lines that cut through the center of my ellipse should hit the midpoints vertical. And really, I don't even need those lines, but this ellipse should come in, it should hit the midpoints of the lines that make up the square. So let's see if we can find the right ellipse that does that. That's pretty close. I am moving this down because apparently I didn't find the exact center. Let me go back just to kind of show you. Let me get a more accurate center point. I will tell you, most of the time you're sketching, finding the center is not the most critical of things. There's my ellipse, basically very close to the center. The minor axis is straight up and down. And then notice how this ellipse is hitting those midpoints. There and there, and here, and here, in a tangential relationship to that line that makes up the square around the circle. Also, just to reinforce, here's my minor axis, and it's dividing this ellipse in half. So that minor axis gave me the angle. Okay, lastly, and this will come into play on many of the assignments that we've got. Let's just say that we already have established our perspective. And what we need to do, I'm not going to use the square this time because sometimes it's difficult to actually draw a square surface. We've talked a lot about proportion. Sometimes it's difficult to draw a square surface in perspective and get that proportion right. So this time, what I'm going to do is I'm just going to pick and draw 3 different ellipses in these 3 locations. So let's start over here, and let's do a vertical ellipse. And so with a vertical ellipse, we need a vertical minor axis. I'm actually going to move that over from where I have that. So there's my minor axis. So when I take my ellipse, all I have to do is set it up on that point, that center point right there. If you're using your ellipse templates, you may need to drop in a major axis, again, just to give you that center point. You don't have this on the ellipse template. And so basically what I'm looking at here is, well, which ellipse would be correct? And I've got this line here, but I want to go ahead and put in, let's make this just a little bit, well, let's leave it at this size. So what I need is I need something over in here, and then I also need on a vertical minor axis ellipse, or an ellipse sitting on a horizontal surface. I need, again, a line going towards one of my vanishing points that I extend out. Maybe I don't need to extend it out. I need a line going towards a vanishing point, and I need, well, I'm going to use both lines going towards the vanishing point. So I'm going to use this one, and right vanishing point and left vanishing point. And so I'm going to sketch this in with a blue line. So we were somewhere in here. Remember, I want it to be close to the, somewhat close to the edge of my ellipse. And so when I pull in this ellipse template again, I look at that, and this area is not equal to that area. And so probably what I need to do is make it a tighter degree ellipse. And all of a sudden, when I look at this, I feel pretty confident in that. And look, even this line that I've got for one of the other ones is giving me a tiny little ellipse over here. So it shows you that you can really use either set of vanishing points, but just in any location on this. So I'll drop in that. And one of the interesting things about this is you can now, in fact, use this to construct a square surface. If you're using your vanishing points, you find where that would hit that line tangent. It should be at those midpoints. And now I've got, if I've used this correctly, I've got the perfect proportion for a square surface, or even the beginnings of starting a cube. Okay, so let's look at left facing. So this would be for the base or the top of a glass that you could then construct more. Okay, so down here, we'll pick this as a point for the center of one of our ellipses. And I want this ellipse facing left. And so my minor axis is going to be going towards the right vanishing point. So that's going to be my minor axis. And what I'm going to need to check my chord, if we go back to this as a reference, to check a left-facing surface, I'm going to need that vertical, and then I'm going to need a line going towards the left vanishing point. My minor axis is going towards the right, but to check it with the chord, I need that left vanishing point. I've already got the vertical drawn in. So let me put a line in there. The minor axis does what? Well, it tells me my angle. So I'm going to line my minor axis the minor axis of my template up with that angle. And if I set it right there on the circle with the ellipse that we have right now, and you look down here, well, that's not equal. So what we need to do is adjust that ellipse. That's the wrong direction. But as I pull it this way, it turns into the correct dimension. So I had to make that one a little bit wider. And so now I've got this area that looks even. That actually looks like it may be a little bit too much right here. So let me go there. And just like I mentioned earlier, I could now use this to construct a perfectly proportioned square surface that ultimately could be going towards a box. Now, one of the things that we talked about on the cylinder exercise is that as this moves, if it was a cylinder or a glass, moves towards that right vanishing point, the ellipse is going to have to get smaller, but the degree should open up and get a little bit wider. And so let's check it. So I'm just going to put a center point right here, and I've got my minor axis. What I'll also need to check the chord is going to be this vertical line, and I need one going towards the left vanishing point, somewhere in here. And so now if we look at this, it looks like I could probably put in a line just a little bit closer to help us check. So if we look at that, that doesn't look right. Let me get one more. If we look at that, that doesn't look even, so I've got to open up that angle until it hits the right angle. So as that cylinder goes backwards, it gets smaller but wider. Okay, so now we'll do one that faces the right. Now this one is above the horizon line, so it's going to be facing, might be a little bit awkward. But to check this, I need what? My minor axis is going to the left, so my chord will be going to the right. Let's put in a blue line going over towards the right. That minor axis tells me what? Well, it's going to tell me my angle. So I line up my template there. And then let me shrink this down. And when I look at that chord, that looks uneven. So probably going to have to open this up a little bit. There's a circle. Now it's got to close. So now those look even. That should give me the correct ellipse. And if I drag this back along here again, if I wanted to make a cylinder in here, it's going to need to be smaller, but probably a little bit wider. And let's see if this one changes so much. I could use, let's see, let me draw in, let's put it here, and let me sketch in another chord line, which is going over towards the right vanishing point. And what I'm going to need to check that chord is also a vertical. And so when I look at that, I haven't changed the degree. This hasn't moved very much relative to the overall perspective setup. So I can drop that ellipse in there. Let's see if we shrink it, if it changes, or if we get wider. That's bad. That's worse. And so there we've constructed those 3 different types of ellipses, both above and below the horizon line, and looked at what happens. I guess the last thing is that we could look down here a little bit further. And let's put one more ellipse down here where we construct everything. Let's find a center point. Let's just put it on down a little bit. Maybe about right here. I'm sketching in that. That's our major axis, but it's only giving me the center point. What I need to construct this and see if it's correct is I need a line going towards the right vanishing point. And I need one, let's go ahead and put one going to the left vanishing point just to help us. And then I'll need a chord line maybe coming down here. And so my minor axis is straight up and down. This is the horizontal surface. My width the size of the ellipse is going to be somewhere in there. And let's look at what this one was. So this ellipse was somewhere in the neighborhood of that. Let's move it down. Let's check that against our chord and look at that chord's not even registering on this side. So we've got to make it wider. And then I'm just going to move it until it feels right. And this is moving way below that horizon line. So there's where my chord checks out. And so there you've got, and you're seeing pretty dynamically how much that ellipse changes as it moves away from that horizon line in that scenario.